Chain rule with natural log. Okay, so we want to find the derivative of natural log of cosine of 2x. Looks like a couple chains. There are a couple of links in that chain, so to speak. Okay, so the idea with the chain rule, chain rule, f of g of x equals f prime of g of x times g prime of x. So the idea is we take the derivative of the outside and we multiply it by the derivative of the inside. So we're going to start by saying that that is, I don't know, u, just to make life a little bit simpler. So the outside here, in this case, would be f of x equals natural log of x, and g of x would be cosine of u. And I'm just saying that u equals 2x just for simplifying things briefly. So then f prime of x equals derivative of natural log of x. Derivative of natural log of x is 1 over x. And then g prime of x would equal negative sine of u. Now, in this case, I understand, this is just to explain the chain rule. This we would then multiply by the derivative of u as well for the chain rule. But focus. So then to go, just to make it semi-reasonable. Okay. So now we're going to put this all together for the derivative. So f prime of g of x is 1 over x. But in this case, x is the g of x, so this would be 1 over cosine of u times g prime of x would be negative sine of u. And that would be the idea of the chain rule. So what we're going to get here then is we're going to take the derivative of natural log of x, or of natural log, which would be 1 over x. And so we're going to get 1 over cosine of 2x. And then we'll multiply it by the sine of 2x using the chain rule we just did here. But then we're going to have to do the chain rule one more time with 2x. So we're going to then have to multiply this by the derivative of 2x, which is, rather negative 2. So we should have negative 2 sine of 2x over cosine of 2x, which would also be the negative 2 times the tangent of 2x. Let's see what we got here. Yep, so it's right here. This would be the answer. So to recap how this works, go through the logic again. So we're doing the chain rule. And we're going to do the chain rule twice because when you have a nested function, does that work? Or is that just a coding thing? I don't know. When you have something that's nested and a function inside of a function, then you have to use the chain rule. Chain rule is, without going too deep into again, f of g of x prime equals f prime of g of x times g prime of x, where g of x is the function that's nested inside of f of x. So the first nested function would be cosine of 2x, but then 2x is nested within cosine. So take the derivative of the first, so it would be 1 over cosine of 2x times the derivative of cosine of 2x, which is negative sine of 2x, times the derivative of the inside of this, which would be 2. And that's the way you work through this one. If you're doing this for like some sort of homework or learning, then I would write out the whole, this is f of x, this is g of x, and then go through the whole process. When you're approached with this sort of thing on an AP test, you really don't have that luxury of showing all your work and really being confident about what you're saying. And so the way I would approach this for an AP exam is you have to have a certain level of fluency. And that's just doing it the way I did here, which is, all right, chain rule once, chain rule twice, put everything together, make it seem reasonable, and then look at what your options are. So when you look at the options, you're like, all right, there's no e involved, so that's not going to be it. You know there's going to be a 2 on the outside because we have a 2x on the inside. And a lot of these have 2's. You know there's probably going to be a sine involved because you have a cosine, and you're going to have to take the derivative of the cosine, so you're going to get a sine. And so this one's probably not going to be correct. This one is like, well, maybe, because the tangent has a sine over cosine. And this one's also kind of a maybe. But you know that you also want to have a 1 over something because of the natural log. So that's how you approach this problem to find using the chain rule with natural log and then double nested functions.